The last video in this section also talks about a special occurrence, and it happens to be called the difference of two squares. And you don't have to write it out this way, but it is one way that you can think about it. Looking at the example that I have on the screen, notice that it's not a trinomial. It's a binomial. It's x squared minus 64. There's only two terms. And we're used to having that middle term. So remember, we'd have two numbers that multiplied to negative 64 that would add to the middle number. But if there isn't a middle number, that means 0 is in there. So x squared plus 0x minus 64. So we are looking for two numbers that multiply to give me negative 64 that add to 0. Now you don't have to write that, like I said, but you do want to think about it like that. And what you're going to end up finding out is that these have a pattern. And let's discover that here. So I know that 8 times 8 is 64, and we can work with that. So x plus 8 times x minus 8. And I need a 1 to be positive, 1 to be negative, because a positive times a negative will give me a negative. And if we just check real quick, negative 8x plus 8x is going to give me that 0, or this, and our x times x gives me the x squared. So what we end up finding out here is we do have the difference of two squares, because x squared is a perfect square and 64 is a perfect square, and we are taking the difference of those two squares. So very creative name there, right? So whenever we have this case, we're just going to take the square root of x to the second, which is x, and we're going to take the square root of 64, which is 8, and one's going to be positive and one's going to be negative. And that is how we're going to factor that. So whenever you notice that you have the difference of two squares, it's very simple. It's just going to pretty much be the square root of each term, plus and a minus as your symbols. And it doesn't matter what order you go in. I could have also written x minus 8 times x plus 8. Okay, so now let's just look at one where we just dive right into it. Okay, this one's a little bit more complex, but again, let's just double check what we've got here. Do we have the difference of two squares? 4x squared is a perfect square because I could break that into 2x and 2x. 49 is a perfect square because I can break that into 7 and 7. And we are taking the difference. So what I'm going to write out here then is 2x plus 7 times 2x minus 7. And this would be our factored answer. And you can check that if you want to, but it will work out. And again, I could have written 2x minus 7 times 2x plus 7, doesn't matter the order. Okay, so I like the difference of two squares because it's once you notice it, it's very easy to factor. Lastly, let's say we've got something like this. It's definitely not the difference of two squares. Remember, you will always want to check, is there something I can divide out of both numbers? So 3 and 27, I can divide both of those by 3, and then we just look at what we're left with. Well, this divided by 3 is just x squared, and 27 divided by 3 is 9. And now we can see on the inside here we do have the difference of two squares, x squared minus 9. So x breaks into x and x, 9 breaks into 3 and 3, and I need a positive and a negative, so this will factor further to 3, x plus 3, x minus 3, and this would be our final factored answer. So you do want to leave that 3 on the outside there to indicate that that is being multiplied by everything as well.